Okay guys, so we have been talking about factoring quadratic equations and using that to solve quadratic equations. But there are a couple special cases which, if you see them, you can factor it really easily right away. It's like a shortcut. So let's first talk about what we've been doing the last couple times, and then we'll talk about these special cases where you can use the shortcut. So in general, what we've been doing so far has been taking a quadratic expression or equation and saying what two numbers multiply together to get me 6 and what two numbers will add together to give me 5. So it has to multiply to 6 and add to 5, and you'll say 2 times 3 is 6 and 2 plus 3 is 5. So to factor this, I must need a 2 and a 3 there, because those will add together to get you the 5 and multiply to get you the 6. Alright, so I said x plus 2 times x plus 3. And checking it by multiplying this out, it is equal to that. And if you need to review that, go back and look at the last couple things we did. But today, we're going to learn the shortcuts. We're going to learn some shortcuts. So let's start with this first example here. B squared minus 16. So what you're going to do is you're going to say, well, what two numbers add to 0 and multiply to 16? If that's confusing you, let me show you this. So the middle term is 0. There's no b in the middle there. So we're really finding what multiplies to negative 16 and adds to 0. What adds to 0 and multiplies to negative 16? Well, 4 times negative 4 would be negative 16, and 4 plus negative 4 would be 0. So that is going to be my answer right here. B plus 4 times B minus 4, because I asked myself what will add to 0 but multiply to negative 16? 4 and negative 4. So I get this. And multiplying it out to check it, I get that. Negative 4b plus 4b equals 0. So b squared minus 16, which is what I started with. So this is the right answer right here. So this is the factored version of that. Another example, x squared minus 25. What two numbers will multiply together to be negative 25, but add together to get you a 0, x is in the middle? What two numbers multiply to negative 25 but add to 0? And you might think 5 times 5 is 25. If I do 5 and negative 5, that will get me negative 25, and they'll add together to get you the 0 in the middle. So this is the answer for that example. And multiplying it out, x times x squared, x times negative 5 is negative 5x, 5 times x, 5x, negative 25, negative 5x plus 5x is 0, so we have x squared minus 25, which is what we started with. So that is indeed the correct factored version. So there's a pattern going on here which will lead to our shortcut. And the pattern is we have plus 4 and minus 4. We have plus 5 and minus 5. So whenever you see a number squared right here with no middle term, you can use this shortcut. So the pattern is called the difference of two squares. Difference because it's subtracting. X squared minus some number squared. So a is a constant. It could be 3, or the last two it was 4 and 5. So whenever you see x squared minus a number squared, it will factor to x plus that number times x minus that number. That's the pattern. So now let's look at some examples and use this pattern to get the answer really quickly. X squared minus 9. I say 9 is 3 squared. So that means this is going to be x plus 3 times x minus 3. And you can multiply that out and check it, and it will get you that. X squared minus 64. So what you gotta say is 64 is 8 times 8. So I can get this by multiplying x plus 8 times x minus 8. And if you multiply that out, you can check that and it will work. Next couple examples. What squared gives you 100? 100 is 10 times 10, or 10 squared. So that's going to give me x plus 10, and x minus 10 is going to multiply together to get you that. X squared minus 4. 4 is what number squared? It's 2 times 2, so it's 2 squared. So x squared minus 2 squared will factor to x plus 2 times x minus 2. So this equals that. And you can check that by multiplying it out real quick. X squared plus 2x minus 2x minus 4, which simplifies to x squared minus 4. So that is indeed equal to this. So that is the factored version of that. Okay, see how fast that is? So whenever you see x squared minus something that's a number squared, you can use this shortcut. Okay. There's a little more places where you can use this. So like this one, 9x squared minus 4. So the rule, you copy this into that big blank on your notes. If it's k squared x squared minus a squared, then it will factor to kx plus a times kx minus a. So the difference is you're adding in these k's here, which is another constant. So this is showing how it works with multiplying stuff out. So instead of just x minus 2 times x plus 2, what if you have 3x minus 2 times 3x plus 2? You'll get the middle term still canceling out because plus 6x minus 6x is 0. And you'll get this times this still right there. So the a squared is still right there. But you'll get a 9 right there from the 3 times the 3x times the 3x. So when you're factoring and it's got a number squared times x squared minus a number squared, you're going to say 4 is 2 squared and 9 is 3 squared. So I'm going to have 3x minus 2 times 3x plus 2. Alright, so the 3 is the k. So this number will add this part when you're factoring it. The rest of it's the same as what we were doing before. So let's look at a couple examples that'll hopefully make that a little clearer. So if you look at example 7, 4a squared minus 25, you say, that's 5 squared, that's 2 squared. Okay, so 4 is 2 squared, 25 is 5 squared, so I'm going to have 2a plus 5 times 2a minus 5. The 2 is from 4 because 2 squared gives you the 4 when you multiply this, and the 5 is just like we were doing before from the 25. Same thing on number 8. You say 9, that's 3 squared. 100, that's 10 squared. So I'm going to have 3x plus 10 times 3x minus 10. So the last number comes from this, and the number with the x comes from the number with the x. So you're taking the square root of this to get those, and the square root of this to get those. And you can multiply those back out and show that that works. So it's a little more tricky when you got this number in front, but just remember all that it will change is just add a term, right, a factor with the x's in those binomials when you factor it. Okay, one more thing really quick. It's very similar. It's called perfect squares. And that's when instead of having like x plus 3 times x minus 3, you have x plus 3 times x plus 3. So remember, x plus a squared would mean x plus a times x plus a. And a could be negative, so you could have x minus 3 times x minus 3. Okay, so I'll just show you the next part, and hopefully that will make this a little clearer for you. So if you have x plus a times x plus a, you'll get x squared plus ax plus ax plus a squared, which will equal x squared plus 2ax plus a squared. Ax plus ax would be 2ax. So when you have a perfect square, and then instead of canceling out, those two terms add together. So whenever you see x squared plus 2 times a number plus that number squared, you can say, oh, that's just x plus a times x plus a, or x plus a squared. So let's do these two examples, and hopefully that will make this more clear. So a is whatever constant number, just like before. So like this one right here, you're going to say 9 is 3 squared. 9 is 3 squared, 3 times 3. And 6 is 2 times 3. If I have twice a number here and that number squared here, then what I really must have is x plus 3 times x plus 3. Or you could write that x plus 3 squared. And that's why it's called a perfect square. It's this thing squared gives you that. Okay. This last one, you say, oh, 25 is 5 squared. Is negative 10 2 times 5? No. but it is 2 times negative 5. That's 2 times negative 5. And 25 isn't just 5 squared, it's also negative 5 squared. Negative 5 times negative 5 gets you 25. So in this example over here, 3 is your A number. In this one here, negative 5 is your A number. So that equals x minus 5 times x minus 5, or x minus 5 squared. And you could multiply those out and they'll give you these. I'll let you do that on your own if you like, because the video is getting a little longer than I want. But thanks for doing the notes, and I will see you guys on Friday.